Oops, wrong Pre Algebra. Okay, good morning. Today we are working on PO39, starting off our next unit. I believe this is unit 7 now. So starting off unit 7, PO39, we are starting off right away with a power objective. So it is super important. This one is I can determine the number of possible outcomes of an event. So in order to determine the number of possible outcomes, we need to know what the probability is. So probability is the likelihood of an event happening. So we have a scale of probability. So our scale goes from 0 to 100. So this is 0. Let me draw this a little bit nicer. Can't draw straight today. So we go from 0% to 100%. In the middle would be what? And then we know 25% and 75%. So 0% chance of happening, it is not gonna happen. 0% chance, not happening. 100% chance, it is definitely happening. We will have this. Then we have this section, it's not likely. If it is under 50%, it is not likely. So if it's over 50%, it is likely to happen. We don't know for certain, but it is likely to happen. The closer you get to 100%, the more likely it is that it will happen. Lucas.
So with 25% usually happens a quarter of the time, and 75% usually happens 3/4 of the time?
No, Matthew. Let me be the teacher, please. It means that that's percent chance of it happening. So when we think about the weather, it's most likely not going to rain today, but could it still rain? Yeah. Sometimes there's a high likelihood, 75% chance that it'll happen. Sometimes it's a 25% chance it'll happen. Doesn't mean for certain. So we can't say 25% of the time it will happen. It's that likelihood. So think more like weather. Okay, it's not always going to happen, but it's less likely or more likely. So the closer that we get down to that 0%, the less likely it is to happen. Is it gonna snow today? I don't wanna say 0% because I'm not Mother Nature. I'm not God. I don't know exactly, but I would say it's darn near like 0.1%. That, it's really small, right? Because you never know, especially with Minnesota weather. So it's really, really small chance of happening versus if it was 99% certain. There's a really good chance it's going to happen, but it's not 100% guaranteed. Do you see the difference? Okay, so to determine how many possible outcomes there are for an event, we need some way to figure out everything that could possibly happen. There are two ways that we can do this. So the first way is doing a probability tree. So let's say we flip a coin 3 times. How many possible outcomes are there? If we flip a coin that first time, flip 1. How many possible outcomes are there? Grace. Which would be what? Heads and tails. So I'm going to say this is my coin. I could get a heads. I could get a tails. So now I'm going to take that coin and I'm going to do flip 2. Now, how many possible outcomes are there for flip 2? What was that, Jude?
4.
Yeah, because if I had gotten a heads, I could flip a heads or a tails. And if I had gotten tails, I could flip a heads or a tails. Now I have to flip 3. So now I have to go to each of these flip 2s. It's still going to be, because I'm just flipping that coin, so it's still heads or tails. So if I flipped a heads here, I could flip another heads, or I could flip a tails. If I flipped a tails, I could flip a heads or another tails. If I flipped the heads down here, I could do heads or tails. And if I have heads or tails for the bottom one. So if you have not written this on your binder sheet, you should. This is how to do a probability tree. Then I wrote really big. I did not leave space for my outcomes. So I'm going to write it really small here. I have heads, heads, heads is one set of outcomes. Then I have heads, heads, tails is another set of outcomes. Heads, tails, heads, heads, tails, tails. Then I could have tails, heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. So how many possible outcomes do I have, Matthew? 8. So there are 8 possible outcomes. The thing that's about doing it this way is it tells you what each possible outcome could be. So we know how many would all be the same, heads, 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 or tails, tails, tails. It tells us what is involved in each possible outcome. Let's do another probability tree. You have 3 pairs of pants and 4 shirts. How many possible outfits can you make? So I need 3 colors of pants. What's one color of pants? Kyle?
Pink.
What's another one? Purple. What's another one?
Blue. Green.
Now I need 4 shirt colors. So these are my pants. What should my shirt colors be? James?
Green.
Lucas?
Beige.
And Matthew? Yeah, I need 4 shirts. So I have 3 colors for my pants, 4 colors for my shirts. So I'm going to set my probability tree up with my pants and then my shirts. So my pants, I have pink, blue, oh, let's do purple. That's what I wrote next. And blue. Then for my shirts, I have green, white, beige, and black. And for the purple, I have green, white, beige, and black. And for the blue, I have green, white, beige, and black. So I'm going to line them all up. For each color pants, I have 4 different shirts I can match it with. You see how that works? Each color pants, 4 possible shirts to match with them. So my possible outcomes, I could have pink and green, pink and white, pink and beige, pink and black. I could have purple and green, purple and white. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes. Lauren, we do have a different method that we can do. Okay, I'm showing us the probability tree method. I do have a second method, and if your way is not my second method way, then let's talk. Olivia.
Oh, I mean, in this case, it kind of is like you could just multiply 3 times 4. Because 3 times 4.
Almost as if I have a second method I'm going to show us. What? Oh my goodness. There's a reason I did the probability tree first. The probability tree is a little bit more to it in what you have to do. In the counting principle, it's a little bit easier. Okay. On our last math packet, I think it was the last one, we had the different clothes outfits and how many outcomes were there. You could set it up with that probability tree. Okay, these with that, and you can figure out the outfits. And then there was the counting principle that some of us had already figured out. So let's look at what that counting principle is.
When you were going H, 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 T, that was the second.
Nope, I said, if you were listening, my voice is not loud today because of my cold, but I said I ran out of room. So I'm going to write it over here. So now let's work on the counting principle. That's why it's important that we're listening, especially when I'm talking quieter. So for our counting principle, we have number of outcomes for each event. So event 1 is my flip 1. Event 2 is my flip 2. And event 3 is my flip 3. How many possible outcomes are there for flip 1? 2. I can get heads or tails. How many possible outcomes are there for flip 2? 2. Heads or tails. How many possible outcomes are there for flip 3? 2. Heads or tails. Then what I do, I multiply them. 2 times 2 times 2, and I get 8 outcomes. So let's look at our clothing. We have shirts. That's our first event. Pants is first. Sorry about that. Pants. Second event is our shirts. And we have number of outcomes. How many outcomes can we have for the pants? Say it louder, Lakely. 3. There are 3 colors of pants. How many outcomes can we have for shirts, Claire? 4. There are 4 different colored shirts. I just multiply our outcomes together, and I get the 12. Lauren, was that your way? What was your way? So you set it up almost the exact same way, except for mine, I set them going vertically, and you set yours going horizontally. But it's still the same concept of the tree. Yeah. So it's the same idea as the probability tree, and you get the same answer. Any questions on our possible outcomes? Kaylin?
So for the probability tree, also you could just count like the H and T's to see see how many there are, because there's 3 of them.
Yeah,
So-
we could just look at the end and say 1, 2, 3, 4, 5, 6, 7, 8. You are correct. We write it out because sometimes they might say, how many times would you get tails in the middle? So we would look at this and say, oh, 1, 2, 3, 4 times I get tails in the middle. If I do it this way, can I tell how many times tails will be in the middle? No. Okay. There may be a time you get a question like that, which is why we need to know the probability tree. Is that the main method that we focus on in this unit? But it is good to know it in case they ask a very specific question. So let's go down.
Well, couldn't you just do 2 times 2?
For what?
Oh, no.
I like it when we answer our own questions. All right. A password with 5 letters, and the letters may repeat. How many possible passwords can be made? How would I set that up? We're not going to focus on the probability tree. We're going to focus on the counting principle. So somebody walk me through how to set that up. And you need to talk nice and loud because my ears are getting a little stuffy right now. So talk loud so I can hear you. Will.
So there's 26 letters in the alphabet, and so make a counting pencil or thing, and then you put an alphabet, and then there's 26.
So I'm just labeling it for us. So we have a number of outcomes. Here, there are 5 letters in our password. So I need 5 spaces. So I need to make sure I have those 5 spaces. Will is correct. There are 26 letters in the alphabet. So there's 26 possibilities for my first event. How many possibilities are there for my second event? Dominic? How many possibilities are there for my second event? You don't need a calculator. 26, because it says letters may repeat. We will have ones that say the letters can't repeat. So if the letters can't repeat, if I had picked A for my first letter, I can't use it for the second letter, so there would only be 25. So this objective, it is very, 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 very important that we read the directions carefully. We need to know if something can repeat or not repeat because it changes our number. How many would there be for letter 3? How many for letter 4? And for 5. And then we know we need to multiply them all. So how many possible outcomes are there, Kyle?
11,881,376.
That is a lot of password possibilities. Just a few.
You might not want to try to break it. Just a couple passwords.
So, oh, look at this. Now it says how many possible passwords can be made if letters cannot repeat. So we set it up the same way. Event 1, event 2, event 3, event 4, event 5. How many possible letters are there for the first event, Matthew?
26.
How many for the second event?
25.
For the third?
25. 24.
Why would it be 24 and not 25?
DRU.
Because if we chose A for our first letter and we chose B for our second, we can't use either A or B for that third. So it's going to keep going down by 1. Now, how many possible combinations are there? Possible outcomes? Will?
7, 28, 9, 3, 6, 9,
7,893,600.
That's gonna be like half as much as that.
Not quite.
a third.
If it was 14 million, then it would be half as much.
That's my passcode. Henry,
So
I'm 15. That's my number.
sometimes it's every outcome is based on the same thing, the letters, the coin flips. Sometimes our outcomes are going to be based on different things. Look at the first one on our second page. You flip a coin twice, and oh, friends, I'm not talking over us today. I know how to do this. You haven't done this yet. Voices need to be off. How should I set up my table for this one? How many events are there? If I flip a coin twice and roll a six-sided dice once, how many events is that total? Fiona? 3. So I have flip 1, flip 2, and the roll. How many possible outcomes are there for flip 1? David? 2. How many possible outcomes for flip 2? Ben? How many possible outcomes for the roll? 6. And then we do our math. So 2 times 2 times 6, there are 24 possible outcomes. So the first step is figuring out what each event is, how many events there are, and how many outcomes there are for each event. So this had 2 flips and a roll, so I knew there were 3 events. Then for each event, you have to figure out how many possible outcomes. Coin flips, different amount than a dice roll. Okay, you set the table up the same way, but it's your job to determine how many events there are and how many possible outcomes there are for each event. Should you label each event? You really want to label your events to help you keep track of how many possible outcomes there are. Matthew, I think it was you that was raising a hand just a minute ago. No? Okay. Are there any questions? No questions? We're feeling confident? Okay, so we are going to have math work time. And then when you're done with the math work time, it's working on your math packet. And if you have not tested out of your works of mercy, it's studying and testing out of works of mercy. Our voices do need to be quiet. If you're watching this at home, I hope you are well, and I hope to see you soon. Have a wonderful day.